Hello everyone. First, I will introduce myself. My name is Tufla Al-Mtairi, and the presentation will talk about the counters and asynchronous counters and synchronous counters and the application of counters and counter design and finally the conclusion. First, we'll talk about counter. Counter is sequential devices to count events and losses. We'll talk about categories. First, we have based on a clock age, and it's have two types: positive age tracker and negative age tracker. And we have based on application, and it's have three types: up counter and up down counter and down counter. Also, we have based on a clock application, and it have two types: asynchronous counters and synchronous counters. And now we'll talk about asynchronous counter, also called rival counter. A clock is fed to first flip-flop. A preceding stage out is fed to next stage clock in both. Slower compared to synchronous counter. And this picture show each asynchronous counter and timing sequence. And now we'll continue the topic with my friend Hassa.
I am Hassa, and now after we finished asynchronous counters, we will talk about synchronous counters. Synchronous counter, same clock source to drive all flip-flops, faster as it compared to asynchronous counters. And this is a logical diagram shows decade 4-bit synchronous down counter. And as we can see, there's a 4 flip-flops, A, B, C, and D. Those are the flip-flops. And every single of flip-flops, every click attach with a single clock pulse, A, B, C, and D. And here we have application of counters. We have a 5 application of counters. 1. Frequency divider. 2. Frequency measurement. 3. Time measurement. 4. A to D converters. 5. Digital clock. And now I finish my part and we will complete with Amjad.
My name is Amjad and I will explain what is 3-bit up container. It's a special type of synchronous container which clock plus replace through the circuit. Main advantage of this kind of container is that it required n number of flip-flops to make NMOD. Replace counter. This NMOD replace container can count two end states, and after the counter resets two initial value main vectors of replace counters include flip-flops are used on toggle mode. Different types of flip-flops with different clock plus are used. In counting sequence, flip-flop with external clock will act as least significant bit LSB. The external clock plus is applied to only one flip-flop. The output of this flip-flop is treated as a clock plus for the next flip-flop.
On the next slide, we see functional table, and now we will complete it with Maha.
My name is Maha, and here we will continue on circuit design. We used 3 JK flip-flops to design 3-bit asynchronous counter. As it is an asynchronous counter, so all flip-flops are not connected to same clock pulse. Rather, output of preceding flip-flops is used as a clock pulse for the next flip-flops. The first flip-flop is provided with the clock pulse while giving high input values at the J and K input pins. This is turn drives the flip-flops and provide high output at the Q output pin. This Q output pin value is provided to the second flip-flops as clock sign while keeping all other steps as same. Similarly, same is done with the third flip-flops. The output of the flip-flops are fed to hex display to show that the circuit is working as a E-bit counter. Thus provide values from 0 to 7, and this logic works circuit is shown below. In conclusion, this project has been instrumental and facilitating our exploration of a drive's options and scenarios by leveraging online resources and user-friendly software tools. The employed software has proven to be exceptionally intuitive and accessible. Through the process of designing this counter, we have successfully addressed and resolved all challenges and queries related to counter, including their concept, type, and functioning. This is the end of this presentation. Thank you for listening.